ground masses are arranged as shown right, calculate the resultant gravitational force on the mass and the origin. Okay? So you have some configuration like this. 3 masses, each of them, so this is M, all of them equals to 100 kilograms. You want to calculate the resultant gravitational force on the mass and the origin. So we are going to calculate the net force acted on this object. Okay, so we call this 1, this is 2, this is 3. So we want to calculate the force acted on the second mass here. Now, so we want to do the force analysis. How many forces acted on the object here?
2.
2, okay. 1 is the gravitational force provided by what, right? Let's call it F1. This is the gravitational force provided by string. Let's call it F3. So we are going to calculate F net equals to F1 plus F3. Okay. Here we have some force fields, like say it has some mass, we have the weight here. In this kind of problem, you're not going to consider weight, right? Unless I say, then here you have the Earth, you want, okay, to add it, it provides some force to this object. Because we are calculating the gravitational force, so you only consider the forces possible for the between the among the 3 masses. Okay. Because I don't even tell you where is the Earth. You cannot find the weight, right? If the Earth is on that direction, then the weight should to that direction. Oh, by the way, here, after we started this part, you have to, okay, change your concept a little bit. Previously, we always say that the weight is always downward. Is it always true? No. Okay. Consider this is the Earth. When you are standing here, what is the direction of the weight? Upward like this. Okay. So, in the ancient time, this is always something puzzled, people. How can one people stand below the Earth? And now we know that, okay, there, at the top of the Earth, bottom of the Earth, the gravitational force is pulling up. So for this person, up direction is here, and down direction is like this. So it's different when we stand above that. In fact, you cannot say this is the top and this is bottom. Okay, there's no difference between top and bottom. In fact, you can only say if it's inward or it's outward. Okay, and anywhere of the Earth. So here now we want to find the net force by adding the 2 forces. So here you can see it involves 2 important steps. The first step, of course, you should be able to calculate F1 and F3 separately. And the 2 calculations can be done by Newton's law of universal gravitation. And then you have to add the 2 forces by vector addition. Okay, because they are not in the same direction, right? Don't forget that. Vector addition is not simply 1 plus 2 equals to 3. Now, let's first calculate the F1 and F3 individually. F1 should be capital G, okay, M1, which is M 100 kilogram, M2, okay, divided by, it's better you just write down the subscript here, okay, in case I give you different masses for these objects. Then this is R1, 2. It's the distance between the object 1 and 2. And, okay, so this is R1, 2. What is this R1, 2 from the graph? Can you do the calculation? Square root of, okay, R1, 2 equals to square root of 2. Okay, any question about this? Do you have any question how do they get this answer? From Pythagorean theorem, right? Okay, you have a triangle here. Okay, anyway, the graph here, you have some triangle here. This is 1 meter, right? This is 1 meter. So this is hypotenuse. Square root of 1 squared plus 1 squared. So square root of 2. Then you can calculate this as G multiplied by M squared divided by square root of 2 squared, or G M squared divided by 2. Okay. Here I don't want to substitute the number for G and M, okay, because I want to postpone this to the last step. And then you can calculate F3, which is G M2 M3 divided by R23 squared. Okay. This is R23. What's the number for R23? It's simply 1, right? So it's G M squared. In this case, all these masses will be the same mass M. So 1 squared equals to G M squared. Okay. Now you want to add F1 and F3. The worst thing you can do is, okay, F1 plus F3 equals to Gm squared over 2 plus Gm squared equals to 3 over 2 Gm squared. Okay, so this will be totally wrong.
How'd you get Gm squared for F3? How'd you get Gm squared for F3?
1/2 plus 1 equals to 3 over 2. But anyway, this is wrong. So.
No, on F3 at the end. Oh, that's the one. Okay. Okay, I got it.
This is just 1 squared. Okay, so we're not going to do addition like that. So what we have to do, we have to find the x and y component for each forces here and add them separately. So what is F1x? So it will be like this. You have F1, you have F3. You want to decompose it to get F1x. You want to decompose it to get F1y. Okay? What is F1x? Should be F1 multiplied by cosine what? This angle is 45 degrees, right, from the geometry. You can identify this is 45 degrees. So cosine 45, is it correct? Negative. Okay, please don't forget, component may be positive or negative. And then Fy equals to positive F1 sine 45 degrees. Now, for F3, it should be easy. What is F3x and what is F3y? What is F3x?
1?
It's simply F3, and this is simply right? Because it's along x direction. Okay, any question here? So this standard manipulation of the components. F3x not 1. Okay, so this is a vector. The vector itself, not the 1, right? Don't confuse the 1 equal, think about the distance, right? Distance is 1. We're not decomposing distance. We're decomposing the force. The magnitude of the force F1 is not 1. It's gm squared over here. Gm squared. Okay, and then for the net force, if you want to get the net force, you just add all these components, right? So you get F net x equals to F1, negative F1 cosine 45 degree plus F3, and F net y equals to positive F1 sine 45 degree plus 0. Okay. And now you can substitute number to calculate. You get F net x equals to negative gm squared over 2 multiplied by cosine 45 degrees square root of 2 over 2. And plus F3 is gm squared. Okay. And this will be square root, okay, negative square root of 2 over 4 gm squared plus gm squared equals to negative square root of 2 divided by 4 plus 1 multiplied by gm squared. So can you give me the number here? Negative square root of 2 divided by 4 plus 1. It should be 0.65, about, okay, roughly 0.65 gm squared, right? This is F net x, and then F net y equals to F1 multiplied by sine 45 degrees. So it's gm squared over 2 multiplied by sine 45 degree is square root of 2 over 2. Okay. So it's square root of 2 over 4. This is 0.35 gm squared. Okay? Any question here? You can check my calculation is correct. I'm not very sure about it. Okay. And then, the idea is that once you get the next direction, y direction, you can calculate F net as square root of F net x squared plus F net y squared. Okay. And then, one of the important points is that this calculation can be simplified because this is okay. And can you see that gm squared can be factored out because this term contains gm squared and it's squared, and this is gm squared and squared. So you can check that after manipulation, you are going to get gm squared multiplied by 0.65 squared plus 0.35 squared. And then you substitute number, finally, you are going to get something easy. Okay, so here, there's the basic idea, I think it's straightforward. So far, you should have very clear understanding. Is to calculate F1, F3 separately, and then do the vector addition. Okay, it involves some quite complicated numerical calculation here. Okay, but with your calculator, you should be okay with that. Any question here? Okay, for the pair homework, you have other configuration. Again, you want to calculate the resultant gravitational force.